Now for continental convergent boundaries, the big thing, mountains, you will also get lots and lots of earthquakes. Now for continental convergent boundaries, they have some of the strongest earthquakes on Earth. We're talking like magnitude 8s, maybe even possible magnitude 9. We haven't seen any yet, but it's possible. And another thing, you will notice there are no volcanoes on this picture. Continental convergent boundaries do not make volcanoes. There is no continental crust sinking into the mantle to get melted. And if nothing's melting, there is no magma for a volcano. Now, the next type is continental oceanic or oceanic continental. Doesn't matter which one you write first. Oceanic crust runs into a continent. And what happens? Well, oceanic crust is dense. And it'll sink under the continent. And as it sinks, unlike the continental crust, it will melt. And that melted rock, which we call magma, is now less or lower density, and it rises up through the crust, melting it along the way, and you get volcanoes. Now, these volcanoes tend to be the explosive type. When you get these ones, they go boom. So something like Mount St. Helens would be caused by this, or the Andes Mountains, those ones as well, or the ones in Central America that you see every once in a while, or technically the ones in Japan as well. So these volcanoes tend to be explosive. You also get mountain ranges and definitely earthquakes. So as this oceanic crust slides under the continent, the rocks will get stuck. They'll build up pressure and they'll move all at once and cause a nice earthquake. Sometimes an earthquake happens out here over the ocean. In that case, you'll also get a tsunami as well. And there's one last thing you get with oceanic continental crust that you don't get with continental, and that's an ocean trench. So this ocean trench over here, as the oceanic crust dips down and drags some of the continental crust with it, the land dips down and the ocean fills in its place. And so you have a deep ocean trench out here. And that's a great way to recognize a continental oceanic boundary. You also have an oceanic trench when you have oceanic boundary as well. So same thing as above, but instead of a continent over here, now you have another oceanic plate. It sinks below the other one. Basically, the plate that sinks below is going to be the older one because it's colder, older, more dense. Same thing when it comes to oceanic plate. And you also get volcanoes, you get earthquakes, you get an ocean trench. The only thing you really don't get is a giant mountain range. So an example of this might be like the Sierra Nevadas or the Cascade Range or the Andes Mountains. Whereas with an oceanic trench, sure, you'll get volcanoes, but they're going to be like scattered islands of volcanoes usually. But everything else will basically be the same, just no continent over here on the right side. Divergent boundaries are areas where tectonic plates are moving apart. Basically, the hot mantle magma is rising up, breaking through the crust, making new crust in the process, and that does push the other crust apart. That's where the slab push comes from in that definition. And as it makes new crust, well, you've got underwater volcanoes, sometimes above ground volcanoes in Iceland right here, and it also pushes the other stuff out of the way. Now, with divergent boundaries, most of the time these occur in the ocean, in the mid-ocean ridge. Sometimes they occur on land, like in Iceland, but also it's possible that there might be a divergent boundary under the United States right now, under Colorado, Nevada, Missouri is a possible one as well. That's why they had a big earthquake quite a few years ago. So it's possible there could be a divergent boundary under North America that in the past was in the ocean and that North America just ran over it. It doesn't really become a divergent boundary until the mantle magma breaks through the crust though. So technically, no, there is not a divergent boundary in the United States yet. It's possible in the future if the mantle magma continues to rise up, but for now, no. So Iceland is a good example where a mantle magma is rising up. Iceland has a bunch of volcanoes. It's becoming bigger every year. The size of Iceland increases. And even outside of Iceland, there's also divergent boundary in the ocean, like the Mid-Atlantic Ridge. It just goes through Iceland and then continues. We also think that Iceland is actually a hotspot as well. So it's got two things going for it. It's a divergent boundary and a hotspot. Now, the last type of more about divergent boundaries. So here's the thing about divergent boundaries. Since they make new crusts, the newest rocks on the ocean should be on the divergent boundaries, right? And as you get farther away from them, it should get older. older rocks away from it, newer rocks right next to it. And so red on this picture is the newest divergent boundary, the newest rocks. Blue is the oldest, and you can see as you get farther away, red, the yellow, the green, the blue gets older and older. Same thing in the Atlantic, newest rocks in the middle, older, 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 oldest, and it goes right up next to the continent. Now, the last type of boundary, and we're talking boundary between two separate tectonic plates, is transform. This is probably what you would think of most of when you talk about tectonic boundaries, but it's actually the least common type. Transform boundaries are where the tectonic plates slide past each other. So in this case, the North American plate is moving to the northish, and the Pacific plate is moving a little bit south in this zone. And what's happening is, well, they get stuck every once in a while, and then they move, and they cause an earthquake, and then they get stuck, and then they move and cause another earthquake. Now, a great way to find transform boundaries is they are made of straight lines. If you find a straight line in nature, it might just be a transform boundary or a fault. Who knows? The only thing these cause is earthquakes. They don't make volcanoes. They don't make mountains. They don't make any of that sort of thing. And then I'll go back in 1 second. I just got to get this slide, and then we'll go back to Divergent. So last thing about transform boundaries, they are not associated with volcanoes or mountains, just earthquakes. In fact, even the earthquakes associated with transform boundaries are not the biggest earthquakes on recorded history. That would go to convergent boundaries, specifically convergent continental oceanic. Continental oceanic have given us the biggest earthquakes in human history. Faults. So faults, when movement occurs along a break in the ground. It can't just be movement, because that's an earthquake. And it can't just be a break in the ground, because that could be anything. It could be like erosion, like the Grand Canyon. Now, the fault type depends on what forces pushed it. Is it being pushed up? Is it being pushed down? Is it sliding past each other? That's what the fault depends on. In this case, these faults are just sliding past each other. And you could actually like walk up to them before they fixed these in the road. You could literally see the road has moved in this upper part a little to the right and this lower part a little to the left. So that's the definition of faults. Let's take a look at the three types. The first type is a normal fault. Seems like a pretty normal name. Normal faults are caused by tension, by the ground being pulled apart. So you normally wouldn't think of that with faults, but it does happen on Earth. In fact, this is a very, very common type of fault, especially around here. Now, normal faults, what happens is rocks, they're very brittle. They don't stretch like a rubber band. So when you try to stretch the crust apart, instead of stretching apart, they just break and fall down. And so what happens is maybe you have like a divergent boundary that got swallowed up by a continent. Maybe you just have a hot spot or something, or a bunch of mantle magma rising up. And this mantle magma just can't break through the crust. The crust is so low density that it just kind of sits under the crust. It wants to come up, it wants to push up, but it just stretches that crust apart. Now, eventually it could break through the crust and make a new divergent boundary, but for right now, all it's doing is just stretching the crust apart, making it collapse on itself. And you can see you get like mountains and valleys and mountains and valleys and mountains and valleys with this. We call this horse and grabens. Let's take a look. So this is what it would look like if you were maybe traveling in an airplane over a horse and graben. You would see mountain, valley, mountain, valley. So basically, in the past, the entire area was as tall as these mountains, but what happened is the valleys fell down. Same thing over here, valleys fell down. And then younger sediment fills in these valleys, so it looks young. Maybe, you've been to this state before, maybe not, I don't know. But this state is full of horse and grabens. The entire state is basically being pulled apart in tension. And so every one of these mountain ranges here with a valley in between it is a horse and graben caused by extension. Let's look at some on the ground level pictures. Mountain, horse, valley, graben. Here's another one. Mountain, valley, mountain. There's another mountain all the way over here. So there's another valley between this mountain and that one in the background. And you can see it's just endless mountain, valley, because extension is a very huge effect. Like, let's go all the way back here. This hot mantle magma is hundreds of kilometers long. It's not a small event like one volcano. We're talking the entire state of Nevada plus part of Utah and some of Arizona this is happening to. Now, the next type of fault is a reverse fault, basically the opposite of a normal fault. Instead of being pulled apart, reverse faults are being pushed together. Compressive stress, kind of like a convergent boundary, Well, convergent boundaries cause reverse faults. And in this case, with red rocks, these convergent boundaries cause a reverse fault hundreds of miles away from the convergent boundary. The convergent boundary was over in California 70 million years ago. Well, part of California. And then what happened is, well, that force, that pushing force, stretched all the way over into Nevada. And these rocks right here, red rocks, actually were pushed out of the ground upwards. Now, this fault is no longer active. There's not going to be an earthquake caused by this reverse fault, and red rocks are not going to be moved up anymore. But deep underground, there is more red rocks that were not pushed up. Some were, some weren't. And in this case, they were nearby you. Strike slip faults are the third type, and these are also in the local area as well. And you'll notice here, look at this. These rocks, this ridge goes down, and all of a sudden it moves over to here and then continues going down. This dark ridge right here is going down, mostly straight, and all of a sudden stops, moves over here, and then continues going down. So this fault basically cuts right through right here. The bottom part is moving to the right. The top part moves to the left. These ones are still active today.